question 15. Question 15 is actually testing you on mole concept as well as particulate nature of matter. Okay, so why is mole concept involved in this question when it looks rather simple? So let's take a look at the question. 20 cm cube of hydrogen, it is mixed and burned in 20 cm cube of oxygen. Why is mole concept involved in this question? It is because they provide you with the volumes, okay, of both reactants. So in this case, whenever they provide you with two information, most of the time you will have to determine limiting reagent, okay, determine the LR. So how do we determine limiting reagent? We will have to look at the mole ratio. Okay, before we look at the mole ratio, I need to remind you that these reactants, they are both gases. So that is when we should be using our Avogadro's law. And what is Avogadro's law? Under the same conditions of temperature and pressure, the same volumes of gases, they will have the same number of molecules, which implies that they will have the same number of mole. So it all comes down to the relationship for gases, huh? Mole ratio, it will be equal to the volume ratio. Okay, so let's write the balanced chemical equation for this reaction first, which is the combustion of hydrogen gas. H2 plus O2, it will give me water, H2O. Make sure to balance your reaction correctly, okay, because this will be able to tell you the mole ratio correctly as well. H2 is to O2. Based on the balanced chemical equation, the mole ratio, it is 2 is to 1. Okay, 2 is to 1. Okay, not 210. Okay, I remove the 1 just in case you get confused. 2 is to 1. All right, so now let's take 20 cm cube of hydrogen as the base to determine the limiting reagent. So 20 cm cube of hydrogen, it will actually require 10 cm cube of oxygen, but you are provided with 20 cm cube of oxygen, correct? Since you are provided with 20 cm cube, when you only need 10 cm cube, this means that oxygen is in excess, okay? The unreacted oxygen, excess unreacted O2 oxygen molecules, they will be present in the reaction vessel after the reaction is completed. Okay, can understand? Apart from the product, which is water molecule, excess unreacted oxygen will also be present in the reaction vessel. So let's take a look at the diagrams. Which of the following diagrams represents the particles that remain in the reaction vessel? All right, for A, you need to also know, okay, or infer, conclude from the diagram given that the black dot is actually oxygen, while the unshaded circle, it is hydrogen. Okay, so A is out because we have already concluded that in the reaction vessel, the excess unreacted oxygen molecule will be present. When you look at B, the ones that I'm boxing up, these are actually oxygen molecules apart from the water molecules that is being present. Hence, B is the answer for this question. Let's take a look at other options. Option C, we have hydrogen molecule, H2. However, you know that since H2 is limiting, right? If H2 is a limiting reagent, it will be fully consumed, meaning that it will not be present in your reaction mixture as an element, as a molecule of the element. Okay, so C is out. D is also out because you will not have atoms of hydrogen and oxygen in your reaction vessel at the end of the reaction. Okay, the answer for this question is B.